In this video, we're going to be talking about parallel lines and transversals. And we're going to use what you know about transversals cutting along parallel lines and take that a step further. Now, if you look over here, these lines are parallel. How do I know that they're parallel? The extra set of arrows. So what happens? We have a bunch of corresponding angles and alternate interior and so on and so forth. And what you notice over here on the right side is that you see the word congruent, 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 congruent. And what's happening? Corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. And lastly, of course, vertical angles are always congruent. Who are not congruent? Linear pair, still supplementary, and when the lines are parallel, consecutive interior angles are also supplementary. So this is going to be really simple. All you have to remember are the 6-angle pairs, and then the two that are the oddballs are linear pairs and consecutive interior angles. And just keep in mind, if you get confused, look at the picture. If they look congruent, then they probably are. Okay, let's move on. Now when I say if they look congruent, they probably are, I mean with respect to this particular exercise, not every picture. But in this picture, I'm looking at these parallel lines. And how do I know they're parallel? The extra set of arrows. And so, does angle 4 look like it's the same size as angle 5? Well, of course not. So, first let's start with the given information. We are given that angle 1 is 65 degrees, and now we're going to find the measure of each missing angle. So, when I look at angle 1, you say, okay, that's right here. This is 65 degrees. Well, who else is 65? Angle 7 is 65. Why? Alternate exterior angles. And alternate exterior angles, according to the previous page, are congruent. Now, as you see, I've stated my reasoning is because they're alternate exterior angles, and alternate exterior angles are congruent, so I have 65 degrees. And this little degree mark is what I'm trying to write right here. Okay, now, I have angle 5 is vertical to angle 7, so 5 must also be 65 degrees. Now, angle 3 is alternate interior to angle 5, and angle 3 is also vertical to number 1. So, angle 3 is our last 65 degree angle. So to recap, we started with angle 1, and I linked angle 1 to angle 7 via alternate exterior angles, and alternate exterior angles of parallel lines are congruent. So 7 is 65 degrees. Angle 5 is vertical to 7, so because it's vertical to 7, it's the same measure, they're congruent, so that is also 65 degrees. Angle 3 is alternate interior angles to 5, which makes them, of parallel lines, makes them congruent, and it's vertical to angle 1, so it's always going to be congruent to angle 1. So those are our 3 other measurements that are 65 degrees. So these 4 angles are 65. What about the rest? Well, angle 2 is linear to angle 1, right? They form a straight line and they're adjacent angles. So that means that they're going to be supplementary. So since it's linear to angle 1, 180 minus angle 1, 65, is going to give us 115. So that's angle 2. And angle 2 is vertical to angle 4, so right off the bat, we know the measure of angle 4 is also 115. And how about angle 6? Angle 6 is alternate interior to angle 4, which makes it congruent because alternate interior angles of parallel lines are congruent. Angle 6 is also corresponding to angle 2, and corresponding angles of all parallel lines are also congruent. 4 is corresponding to 8, and corresponding angles of parallel lines are congruent. 8 is vertical to 6. They're congruent as well. So 8 is the same as 6 because they're vertical. 6 is the same as 4 because they're alternate interior. 4 is the same as 2 because they're vertical. So as you see, there's really only 2 unique measurements in this whole picture up here. There's only 2 measurements. One was given and the other was 180 minus 65. So let's go ahead and fill this in and move on. So I have my reasons filled in for angle 8 down here. Angle 8 is vertical to angle 6. It's also corresponding to angle 4, and it's alternate exterior with angle 2. All of those, if you look at above at the sheet, point to the concept of congruency. Okay, so that's a nice numerical example. So just to reiterate, I think you realize now it's important to understand who corresponding alternate interior, alternate exterior, and vertical angles are. Those are all of the congruent angles. And my consecutive interior and linear pairs are going to be my supplementary. Now let's try another numerical example. This is example 4, and the two pieces of given information we have in example 4 is that the measure of angle 12 is 121 degrees, and the measure of angle 6 is 75 degrees. And then we want to be able to fill in this whole box of information. So let's just nip away at it a little bit at a time. First, let's put our given information in. 121 is here, and 75 is here. Now off on the side, it might be helpful to understand what 180 minus 121 is, because we're bound to bump into a supplementary angle, and what 180 minus 75 is, because we're bound to bump into supplementary angles there. So go ahead and calculate that. Press pause and do the subtraction. So I get 59 and 105 respectively. So we're going to need these. Now I come over here and I see I have an X here, right? And that means that angles 1 and 6 are vertical, so angle 1 must be 75 degrees as well. Down here, another X, which means 7 and 12 are vertical, so 7 is 121 degrees. Then I notice that 7 and 8 right here are a linear pair, so 180 minus the 121, we already did that over here, that's 59, and 11 and 12 are a linear pair, or 11 and 8 are vertical. Either way, that's 59 degrees. Now I noticed that I have the extra set of arrows here, which means that these are parallel lines. So this line here is a transversal. So that means that 6 and 10 are consecutive interior of parallel lines, which makes them supplementary. So 75 plus something equals 180, and we already did that subtraction over here. So that's going to be 105 degrees, which makes 13, 105 degrees. And then I know 180 minus 105 takes me back to 75, and 13 and 14 are a linear pair. Right? I have that straight line, adjacent angles, so this is 75 degrees, and it makes angle 9 also 75 degrees. And angle 9 and angle 6 are alternate interior, which means they're the same, and they are. That's 75 and that's 75, so that's pretty good. Now, what else can we do? Let's take a moment and think. I'll highlight the other transversal here. So we got this other transversal, and that makes angle 8 and angle 4 alternate interior, which makes 4 59 degrees. And if 4 is 59 degrees, angle 3 is vertical to 4, because I have the X, that's 59 degrees. And now I want to take a moment and think about this whole big angle right here is 180. So if I take 180 and I subtract out the 75 and subtract out the 59, I'll have what's left, which is angle 2, and coincidentally also angle 5, because it's vertical to 2. So take a moment, do that subtraction, and let's place those values into the drawing. I got 46 degrees. So I think at this point now, it's just a matter of copying all of those values into our box. So go ahead, take a moment, copy those all into the box, and then move on. Okay, and I have my completed box. 75 degrees, 46 degrees. Don't forget your little degree marks. All right, and that's the whole kit and caboodle, all filled in nice, nice. What was the key? Work the drawing first, then fill in the boxes. Now we move on to the more algebraic versions, and this is actually going to be a little bit easier. All I need to do is try to find a relationship that links the two given pieces of information. For these two, it is corresponding, right? These are corresponding angles of parallel lines. So corresponding angles of parallel lines implies that they're congruent. If they're congruent, then I just set the terms equal. So 58 equals 5x minus 2. To solve for x, all we're going to do is some simple algebra, add 2 to both sides. I'm going to get 60 equals 5x, divide by 5, divide by 5, x is equal to 12. I'm all set. Might just want to come over here and say, well, 5 times 12 minus 2 is 60 minus 2 is 58. Check. We should be in good shape. We've solved x. Move on. Again, trying to find a relationship that relates to two angles. So right here and right here, these are alternate interior angles. So I start with my relationship, alternate interior angles. Okay, which means what? When the lines are parallel, these lines are parallel. That was given to us in the instructions. So alternate interior angles are congruent. If they are congruent, then we're going to, you guessed it, set the terms equal. 7x minus 1 equals 125. Add 1, add 1. 7x equals 126. Divide by 7, divide by 7. And x is equal to 18. Come back up here. 7 times 18 minus 1. Double check that, which is 126 minus 1, or 125. And that's what we said it was. Beautiful. Move on again. What's the relationship between these two angles? They're both on the inside on the same side, so they are consecutive interior angles. If you look on that sheet, that means that they are, remember, linear pairs and consecutive interior angles are the only two that are supplementary. So what does that mean? That means that two things add up to equal 180. And who are those two things? 9x plus 2 and 133. Now we're going to go into combining like terms. 2 and the 133 are like terms, so that's going to be 9x plus 135. Whoops. Got a little reckless with my 5 there. Equals 180. I'm going to subtract 135 from both sides, right? Remember, the goal is to isolate the variable using inverse operations. 9x, that cancels out. 180 minus 135 is 45. Divide by 9, divide by 9, and x is equal to 5. Come back up here. 9 times 5 plus 2 is 45. Plus 2 is 47. And we said that this angle here and this angle here add up to be 180. So 47 plus 133 is, you guessed it, 180. Check. Move on. Now, this time we have an x and a y to solve for. So first I'm going to try to do something that I can solve, right? So I see my x is here, my x is here, and this third player involves a y. So I can only combine, I can only write algebraically something with one variable. So I got the 8x minus 31 and 6x plus 3. What is their relationship? They are alternate interior angles, which implies that they are congruent. So if they're congruent, then I'm going to set those terms equal. So 8x minus 31 equals 6x plus 3. Now what? Inverse operations. Subtract the 6x from both sides. I get 2x minus 31 equals 3. The 3 wasn't touched, so it just comes down. Add 31 to both sides, and I get 2x is equal to 34. Divide by 2, divide by 2, and I'm going to get x is 17. So I'm good for the x. Now we have to focus on the y. So it might be a good time to press pause and make sure you got everything here, because I'm going to erase this and clear the board. So I'm looking at the value of 5y plus 35 and 6x plus 3. And I'm thinking that these are consecutive interior angles. Now it is worthy to note that 8x minus 31 and 5y plus 35 are a great example of a linear pair. Consecutive interior angles or linear pairs, either way, points to a supplementary relationship. But again, I'm just going to pick the consecutive interior for no other reason other than that's the one I chose to focus on. That means that they are supplementary, which means that two things add up to be 180 degrees. And what are those two things? The 6x plus 3 and the 5y plus 35. But my problem lies on this side over here. I can't combine the x's with the y's. I know x is 17, so what I want to do is I want to make this an actual value. So what is 6 times 17 plus 3? That's going to be 105. So I'm going to say that, hey, I already know the value of this 6x plus 3 angle is 105 degrees. And when I add that to the 5y plus 35, I should get 180. All right, so now let's combine like terms. So I got my 105 and my 35. So that's going to be 5y plus 140 equals 180. Remember, when you're combining like terms, you're not doing inverse operations. But now I'm crossing over the equal sign. So I subtract 140. I subtract 140. I get 5y equals, that cancels out to 0. That's 40. Divide by 5. Divide by 5. Y is equal to 8. So now I have my answer for y, and I have my original answer for x. We're good to go. And so here we're faced again with x's and y's. So what I notice, I got my parallel lines, all right, my transversal, and it looks like our x's are consecutive interior angles. So consecutive interior angles implies that we have a supplementary relationship, which means that I'm going to add two things up and set them equal to 180. So I have, on the one hand, 18x minus 44, and on the other, 8x minus 10. Now let's talk about combining like terms. I got my 18x and my 8x. That's going to give us 26x. And I got my negative 44 and my negative 10. That's going to be a negative 54. Still equals 180. Inverse operations, to start moving things around, add 54 to both sides. I'm going to get 26x equals, it cancels out, 180 plus 54 is 234. Divide by 26, divide by 26, and I get an x value of 9. So we got the x all squared away. Now we're going to take 9 and we're going to substitute it in for these x values. Let's do it for both the 18x minus 44 and the 8x minus 10. Take a moment, get this all into your notes. I'm going to clean this up and give myself some space. Now what you should notice is that I have calculated the value of this angle here, 18 times the value of x equals 9. 18 times 9 minus 44 gives me 118. So this angle here is 118. And then 8 times 9 minus 10 is 62. This angle here is 62. When I add those up, I get 180. So I feel comfortable about both of these angles. Now, we need a relationship that relates the 13y minus 38 with one of those angles. So if I were to go with this one right here, they're a linear pair. If I were to go with this one right here, they're corresponding. I'm going to solve both of those just to show you it doesn't matter which one you choose. All right, so walk along the thought process with me. If I use the linear pair relationship, then that's going to bring me to this process. And so as you follow down, I have linear pair, implies supplementary, implies that two things add up to be 180. That's 13y minus 38 plus this angle. And that 8x minus 10 was worth 62 degrees. So 13y minus 38 plus 62 equals 180. As you follow the algebra down, I get y equals 12. Or, if we follow along with the concept of the 18x minus 44 in this, they are a corresponding pair. So I just want to circle that. These guys are corresponding. So if I follow the corresponding yellow brick road here, corresponding implies congruency, which means that they're equal. And this 18x minus 54, or minus 44 rather, was worth 118 degrees after I substituted the value of x in. So 13y equals the 118 degrees. Follow the algebra down, and what do I get? A y of 12. So either way, I'm going to get a y of 12 and an x of 9. So those are my two answers. And again, we are faced with a dilemma. Where do we start? I think we're going to start with the x's because we have two of those, and it looks like these two here are corresponding. Corresponding implies congruency. Congruency means we're going to set them equal. So 5x plus 54 is going to equal 9x minus 2. Now again, we have some options here, so I think I would like to subtract the 5x from both sides to keep that coefficient of x positive. That leaves me with 54 equals 4x minus 2. Add the 2 to both sides, and I'm going to get 56 equals 4x, divide by 4, and it looks like we should get an x value of 14. Now I'm going to take that 14 and I'm going to substitute it in for the value right there to get 9 times 14 minus 2 and get an actual degree amount for that angle. So it looks like I get a value of 124 degrees. That means this angle right here is 124 degrees. So I'm going to use that information and the fact that right here, these guys are a linear pair. So that means that this angle and this angle add up to be 180 degrees. So again, as usual, I'm just going to steal a little bit of space and then I'm going to work that out. So make sure you press pause and have all this in your notes first. So I've taken the liberty of highlighting some stuff already. I got this linear pair relationship right here. So that means that linear pair implies supplementary. Supplementary means I'm going to add up two things and set them equal to 180. And those two things are the 10y plus 6 plus the measurement of this angle, because 9x minus 2 is not helpful when I'm solving for y. I need the actual value. So we had substituted 14 in for x to get this 124 degrees. Now I'm going to combine the like terms that I see here. So that's 10y plus 130 equals 180. Subtract 130 from both sides. And I'm going to get 10y is equal to 50. Divide by 10, and y is equal to 5. So I add that to my final answer up here, and we are all set with this problem. Now let's just highlight what's going on here. This last problem, I have these guys are vertical, so once I can get a value of x, I can get an angle amount and solve for 11y minus 32. And I noticed that my two angles up here are consecutive interior. So I'm just going to set this up here. I got consecutive interior implies supplementary, implies that we're going to add things up and set them equal to 180. And that's the 3x minus 16 and the 6x plus 7. Okay, you finish that and get the x value. Then when you're done, I want you to get that x value and I want you to substitute it in and get the value for this angle, right? And once you get this angle, it's going to be some number. That number is going to be part of how we solve for y. Now the y, keep in mind we had this vertical angles business, so whatever that number is, right? Vertical angles implies that things are congruent, which means that we're going to set things equal. So whatever this number is, we'll put it over here. It'll be a value, and that's going to be equal to who? 11y minus 32, and you should be able to get a value for y. So that's how you're going to wrap up this work. You're going to come with the x and y values for number 13. And that's a wrap, folks. See you soon.